Welcome to Klein's Geometry. This is lesson 10-8 and we're going to learn and apply the formula for the volume of a sphere. Formula right here, volume equals 4/3 pi r cubed. And we're going to learn and apply the formula for the surface area of a sphere. Right here, surface area equals 4 pi r squared. Now notice volume, they both have 4's in them. Volume is cubic units, and notice there's 4/3, there's a 3, and the radius is to the third power. So think cubic units, I'm going to raise my radius to the third power, and I've got 4/3 as my coefficient. Surface area is square units. And notice we're only going to square the radius here. And we have a 4, but nothing underneath. Okay, it's just 4 and the radius squared. So try to keep these straight in your head and pause the video for a minute and put them in your notes, please. Okay, glad you're back. Let's talk about what this sphere looks like, some vocabulary parts of the sphere. A sphere is simply a locus of points in space, a fixed distance from the center. Just like a circle has a center and all the points around it are equal distance, well, a sphere, it's 3D, same thing. The radius of the sphere connects the sphere to a point to any point on the sphere. So notice that could be a radius. You could have a radius to here, you could have a radius to out here, radius over here, any place on the surface. Hemisphere is half a sphere. And a great circle is if I cut my sphere right in half, think about cutting an orange in half, it would be that circle that you would see when you cut it in half. That's your great circle, okay? Now to find the volume of the sphere, all we do, just like with all of our finding dimensions, is we start by writing down the formula. We think volume, cubic units, 4/3, pi r cubed. Then we look, now don't be tricked by this. Notice this is the diameter that they gave us, 24. Don't use that. We need a radius in the formula. So make sure you cut that in half, 24 divided by 2, and get, I don't know why it says 6 here, we get 12 when we do that. Here's a 12 here. 4/3 pi times 12 cubed. When you're putting this into your calculator, cube your 12, and it says give it in terms of pi. So the pi is just going to come down. Think of it as you're calculating 4/3 times 12 cubed. Do the exponent first, 12 cubed, and then times 4 divided by 3. And you will end up with 2,304 pi cubic inches, okay? And that's your answer. That's all you have to do. Make sure you use your units. So the biggie is don't be tricked by a radius. Or by a diameter, use the radius. Okay? Now, we might have to work backwards. If I wanted to find the diameter of a sphere and I knew the volume, well, I still write down your volume formula and set this equal to the volume. And then we're going to just work backwards. Okay? Now, the first thing I would notice is I can divide by pi. And those are going to cancel out on both sides. And then when you're getting r cubed alone, you're really thinking multiply by the reciprocal. So I'm going to multiply by 3/4. Okay? So 3/4 times 36,000. And it's going to get me 27,000. Now I need to cube root my answer. If you think about cube rooting, I want to make sure everybody knows how to do this. Go to your math key and see this cube root right here. It's the 4th selection down. Here we go. So I'm going to go down to my 4th selection down, cube rooting, and I'm going to put in 27,000. And I can see that 30 times 30 times 30 is where I get 27,000. So when you cube root it, you know your radius. Okay? Now, this is nice. We've got our radius, but we're asked to find the diameter. Well, if we know the diameter, we divide by 2 to get the radius, so I know I just multiply that by 2, and I will have my diameter. So to answer my question, the diameter is 60 centimeters. So start with your volume formula, because they gave you volume, plug in what you know, work backwards, divide by pi, those will cancel out, multiply by the reciprocal, and then take the cube root, math, number 4 selection, double it to get the diameter. Now, what if you're going to look at something like this? Sporting goods store, we're going to compare some things. Sells exercise balls in 2 sizes. We have the standard 22-inch diameter and the jumbo 34-inch diameter. And the first thing you're thinking is, that's diameter, Mrs. Klein. I'm not using that in my formula. I'm using the radius, so I'm going to cut those in half. So how many times as great is the volume of the jumbo ball as the volume of the standard ball? Well, let's find both of them and divide. That's all we have to do. Standard ball, well, I'm going to use 11 for the radius. Write the formula, plug in 22 divided by 2, or just 11, and I know I've got about 5,580, okay? The jumbo ball, well, I'm going to use 17 for the radius, 34 divided by 2, and I'm going to plug that into my formula and get 20,580 cubic inches. Now, to find out how many times as great it is, you're doing the same thing we've done every time we've compared. New divided by old. So you do 20,580 divided by 5,580, and you'll find out that the jumbo ball is about 3.7 times as great. So you're thinking new divided by old equals 2,580 divided by 5,580, and you're going to get about 2.7 or 3.7. So that's how much bigger that jumbo ball is. Good value if you want a jumbo ball. Now, let's look at that surface area formula. If we want to find a surface area of a sphere with diameter 76 centimeters, notice they're doing it again. They always give you a diameter, and you always need radius. So make sure you're cutting that in half, okay? Write down your formula. Remember, this is surface area. I'm only going to square my radius. There's no 3's at all in the surface area. 3's come in volume, which is cubic units. I'm going to plug in my radius, which is going to be 38, half of 76, and you just work it out. That's all you need to do. In terms of pi, I'm going to do 38 squared times 4. The pi is just to come along. Comes along, don't have to mess with it. Now, working between these formulas, you get a little of each. So now, let's say that I want to find the volume of a sphere, and I know the surface area. Well, I'm going to start with my surface area, because that's what I know, and I'm going to write down the formula, and I'm going to put in what I know. Now, I'll divide both sides by 4 pi. That'll cancel out, and I'll have radius squared. And on this side, I have 81. Square root that, you get radius is 9. Okay? Now that I know that from my surface area formula, I can just plug that into my volume formula, put in 9 here, and 9 cubed times 4 divided by 3 is 972 pi, and its volume, so another typo of mine, if it's volume, my inches have to be cubed, don't they? So figured I better fix it now before you told me about it in class. Okay? Now, one more thing, find the surface of an area of a sphere with a great circle with an area of 49 pi. Going back to the vocabulary at the start of the video, great circle is this big circle if you cut it in half. So I know that's 49 pi, and that's just a circle area formula. So I start with a circle area formula, because that's what I was given. Plug in my 49 pi, divide by pi, square root my answer, and get the radius is 7. Plug that into my surface area formula. 7 squared is 49 times 4, 196 pi. And this is square miles for that area, so I've got square miles for my surface area also. Okay? So whatever they give you, start with that formula, plug in what you know to get your radius. Then you can answer anything. Talk about changing dimensions, just like we have in the last 2 videos. Exploring the effects. If the radius of a sphere is multiplied by 3/4, what's going to happen to the volume and surface area? Remember, change in volume is always the scale factor cubed. So I'm going to say, okay, then I'm going to take 3/4 and I'm going to cube it. That's 3 times 3 is 9, times 3 more is 27. Here I've got 4 times 4 is 16, times 4 more is 64. So the new volume will be 27/64, the size of the old volume. What about the surface area? Well, that's going to be the scale factor squared. So for my surface area, the change will be 3/4 squared. 3 times 3 is 9, and 4 times 4 is 16. So all you need to do to find the change in volume, find your scale factor, cube it. All you need to do to find the change in surface area or area, find your scale factor, square it. Okay? Now, these composite figures get kind of interesting, so let's talk about this a minute. Find the surface area of this composite figure. This is like a cylinder, and it's got a scoop out. It's got a hemisphere taken right out of it. So when I think about this cylinder, I'm thinking I've got the lateral area, the sides of the cylinder, and I have a circle down here, one base area. I don't have two because this one's gone, it got scooped out, but I have a hemisphere, half of a sphere, the surface area for half of the sphere right here. So what I'd like you guys to do is start by saying, oh excuse me, we don't want volume, we want surface area. It's going to be the lateral area of the cylinder. Please wait, Dan. Plus one base area, plus the surface area of the hemisphere. Okay? So for the lateral area of a cylinder, 2 pi r times the height. Remember the circumference around times the height. Plus that base area, that circle, pi r squared. Plus, since I have a whole sphere, the surface area is 4 pi r squared. For half of it, it would be 2 pi r squared. So I'm going to write down this formula. I'm going to plug in what I know. I look at this and I see my radius is 3 and my height is 5. And here my radius is 3 squared, and here I've got to put in the 3 squared also. Now if you do all the numbers, because there's pi in each of these, so I can just bring that pi along. 3 times 5 is 15 times 2, I've got 30 here. Here I've got 9 pi here. And here I've got 9 times 2, 18 pi. So I can add those up, and I end up with 57 pi cubic feet. The big thing is to analyze it and make sure you're in the right place when you look at your picture. Okay? So summary, volume of a sphere, cubic units, put a 3 under the 4, cube the radius. Surface area of a sphere, square units, square the radius, no 3's in the formula. Always use the radius in your formulas. If you have the diameter, make sure you divide by 2. And remember, in dimension change, for surface area, the change is the scale factor squared, and for volume, the change is the scale factor cubed. See you in class.